Hi students, now I am beginning a new video for engineering students. They find engineering mechanics a bit difficult, so I'll solve many few thousand problems. So let us begin with engineering mechanics 1 from coplanar concurrent force systems. Now I think it is visible to you a ball of weight W 6000 Newton. This is a ball, its weight is 6000 Newton, is kept on a smooth surface, means there is no friction, rests on a smooth horizontal plane. Two strings AB and AC. AB is one string, AC is another string, both are connected to its center. Two strings AB and AC are attached to its center as shown in the figure. AB and AC passes over frictionless pulley. AB is passing over this pulley. This pulley is frictionless, means there is no friction. AC is also passing over a pulley here, that is also frictionless, means no friction, smooth pulley. And this pulley is carrying a load 3000 Newton, and from this pulley there is a load of 1000 Newton. P 1000 Newton, Q 3000 Newton, and this string AC makes an angle alpha. Now find alpha when the ball is in a position of equilibrium, and also find the pressure R between the ball and the plate. Now what do you mean by equilibrium? Means the net force on it is 0, right? So in your +1 +2 physics, instead of load you are saying tension. Now look, this is applying a force downward, 3000 Newton, and this mass is not going down nor going up, so it must be balanced by an equal force called the tension. Let it be T1, and as you know, tension is always away from the mass. From here to here it is the same string, so this is also the same tension, T1. So let T1 is equal, therefore T1 is equal to 3000 Newton. And look at this one, this load is equal to 1000 Newton acting to this side because of its weight mg. This 3000 Newton is due to its weight mg, right? Now this is neither going down nor going up, means it is in equilibrium, so there must be an equal force in the upward direction, that is the tension T2. So T2 is balancing this, so T2 is equal to 1000 Newton. Now look, from here to here this is the same string, so here also the tension is also T2, right? Now look, we know from your previous classes, if there is a force F like this, this angle is theta, then this is equal to your F of cosine theta, this is equal to your F of sine theta. If this is not theta, this is alpha, this will be F of cos alpha, this will be F of sine alpha. So similarly here, this is your tension T1, so and this angle is alpha, so this will be your T1 cos alpha, and this will be your T1 sine alpha. Fine. So now look, so the conclusion from here is this ball is neither going to this side nor to this side, neither it is going up nor it is going down. So therefore to this side is your T1 cos alpha is balancing the force T2, and T2 is how much? T2 is same thing as 1000 Newton. So T1 cos alpha is 1000, right? Now that is same thing as saying this as well as this, both are in the horizontal direction, that is along x-axis, means sigma fx is equal to 0, the condition for equilibrium. And similarly we have to, condition for equilibrium is also sigma fy has to be 0, condition of, means along x-axis the net force is 0, along y-axis the net force is 0. Now something interesting to understand here, had this ball been alone here without this string, had the ball been alone without being connected by AC, it would have applied a downward force 6000 Newton. had this ball been alone here, means like this, then it would have applied a downward force 6000 Newton. Since it's spherical, this is touching the surface at a single point, therefore this is the pressure, force per unit area. But since it is connected by this string which has a tension T1, the component of this T1 along this direction, that is equal to T1 sin alpha, is not allowing this ball to apply a downward force 6000 Newton. It is pulling it up slightly. So the force here, downward pressure, will be less than 6000 Newton. So but due to T1 sin alpha, it is pulled up. So the pressure is less than 6000 Newton. Let the pressure is R. Let the pressure is R. Now, along this direction, the force has to be 0 for equilibrium, condition for equilibrium. Now that is sigma Fy is equal to 0. Now look, 6000 Newton is downward and T1 sin alpha is upward. If the ball has to apply some pressure, then this 6000 Newton must be greater than this. Then only it will be able to apply some pressure. So 6000 minus T1 sin alpha, 6000 minus T1 alpha, T1 sin alpha is the pressure R. Since it is applying some pressure, 6000 is original weight, that is downward. Due to this T1 sin alpha is acting upward. So the ball, instead of applying 6000, is applying little less than that. And how much is that? Now 6000 minus T1 sin alpha. So 6000 minus T1 sin alpha is the pressure. So for 6000 I put 6000. T1 is given as 3000. Sin alpha is equal to R. Now from 1, let us find out. From 1, T1 cos alpha is 1000. From 1, T1 cos alpha is 1000. So T1, I explained you 3000 cos alpha is 1000. 3 comes to this side, 1000 over 3000, 1 by 3. Put it in a calculator. So alpha is equal to cos inverse 1 by 3. And this comes out to be nearly 70.53. You need a scientific calculator. This comes out to be 70.528 something. So it is nearly 70.53 degree. Now put this value of alpha here. Now from here your R is equal to 6000 minus 3000 sin alpha, 6000 minus 3000 sin alpha. I put it here. So this comes out to be 3171.6 Newton nearly. You need a scientific calculator for all these things. They are readily available in Google Play Stores apps. No need to buy a calculator. You can use scientific calculator apps, right? Okay.